Hello everyone, I am Dr. Godan Raman. In this session, we are going to discuss with Fourier cosine transform problem. Find the Fourier cosine transform of f of x equal to e power minus ax, a greater than 0, and hence evaluate 0 to infinity cos sx by s square plus a square into ds. So first to write the formula for Fourier cosine transform f of x. So this is a notation for taking Fourier cosine transform. 2 by pi square root 0 to infinity f of x cos sx into dx. Now substitute f of x value 2 by pi square root 0 to infinity e power minus ax cos sx into dx. Now I am going to integrate with respect to x. Direct formula, because Bernoulli function we are going to apply, but direct formula is nothing but integration of e power ax cos bx dx equal to e power ax divided by a square plus b square, a cos bx, b sin bx. So this is a formula. In this formula, to compare here, a is nothing but minus a, where a here minus a, and then b s. Therefore the integration, what is the value? A equal to minus a, b equal to s. For the right hand side is the integration value. After the integration, the right hand side is the value. Therefore I just replace here in this right hand side value a minus a, b s square. Here minus a s. This is a s. So just changes. Therefore square root of 2 pi, then e power minus ax divided by a square plus s square minus a cos sx plus s sin sx. The limits 0 to infinity. Now when I substitute upper limit and the lower limit, where to substitute? In x. In this place, when I substituted upper limit infinity, the infinity where should substitute? The value is nothing but infinity plus any value infinity, then addition, subtraction, whatever, the values are infinity only. Therefore only e power minus infinity 0, 1 by infinity 0. I think when I apply e power minus infinity, the whole term, the 2 by pi, e power minus infinity 0 into any terms are 0. So don't substitute infinity here. When I substitute infinity, infinity plus infinity, infinity into any terms of infinity. So just consider e power minus infinity 0. So upper limit 0 minus of the lower limit e power 0 a square s square minus a cos 0 s into sin 0. Now e power 0 value 1, cos 0 1, sin 0 0. Now just substitute here square root of 2 pi minus into minus plus a divided by a square plus s square plus a square. So this is a Fourier cosine transform value. So the question is only Fourier cosine transform, then this is the answer. But in the question, hence evaluate some integration of the part. In this integration, any square term is given, then we just find Parseval's identity. But here only x terms to x term, then they are using inverse Fourier cosine transform. Therefore inverse Fourier cosine transform is nothing but f of x equal to 2 by pi square root of 0 to infinity Fourier cosine transform of f of x cos sx into ds. Now this 2 by pi square root 0 to infinity, then substitute Fourier cosine transform value 2 by pi square root of 2 by pi a by s square plus a square cos sx into ds. Now root 2 pi is 2 pi, 2 by pi. 0 to infinity a by s square plus a square into cos sx into ds. Now what is the term? Here the constant. Now take the constant out. What is the constant? This is a 2 pi. I think this is a value 2 pi. Root 2 pi into root 2 pi, 2 by pi. Now when I am taking constant out, 2a by pi, 0 to infinity cos sx by s square plus a square into ds. This is a f of x. Now the question is, hence evaluate the part. This part is the question. Therefore 0 to infinity cos sx by s square plus a square ds. I'll keep with left hand side. Now other term to take it in the right hand side or left hand side, whatever. Now this term is moving to pi by 2a f of x. Pi by 2a f of x. Now substitute f of x value. The f of x nothing but 0 to infinity cos xx by s square plus a square into ds equal to pi by 2a e power minus ax. So this is our value when we apply inverse Fourier cosine transform. So this problem we used Fourier cosine transform and inverse Fourier cosine transform. Thank you.